All right, guys, welcome to another episode of CUDA Education. Today is a very quick video. So you remember in the last video that we did, we messed around with this multi-draw indirect branch in our code, right? So basically it was a difference of submitting all the commands in one shot and having everything implicitly being processed with this one command, right? This cmd draw indexed indirect, right? So we had it where everything was encapsulated in this one command, right? And this being able to do this was dependent on having a GPU that was able to that had this multi-draw indirect feature, and of course the feature being enabled. Okay, so in the last video I briefly touched on this topic, and for my GPU it is enabled, so this runs. Okay, so when we run this, we discovered that we get our normal behavior for this application, which I'm sure you guys know a million times over. I'm running at 200 plus or 190 plus frames per second, all of that good stuff, right? We've been through this many times before. Fine. All right. So then now I was like, okay, I want to see what's going on with this. So even though my GPU can have it enabled or has it enabled, I'm gonna mess with the script to basically run when as if I don't have it enabled, right? So basically I take this branch right here, the processing for this branch, and I put it up in the up in the branch of the if statement where it's true. So this is true, this is false, right? So I basically comment out my one one command instruction. Notice that everything is sent as one shot here. And instead of doing that, now we are boiled down to a for loop, and we're literally we're literally for looping through all of the indirect commands, and we are issuing commands one by one, piecemeal. Okay, so when I do that and I run our application, all of a sudden now our application goes from 190 plus frames per second down to 30 plus frames per second. Okay, and we also notice it because when we zoom in and out, we could actually see the colors changing. When we do it the fast way, we don't, our eye doesn't catch the colors changing for the level of detail, right? And and that's because now we're doing things piecemeal, and we're subject to this for loop, right? Everything is not submitted one time, and of course we lose time and efficiency when we submit the stuff piecemeal. Just real quick, I will revert back to when things are fast and normal, and we will see that when we run it and I scroll in and out, that you could see that your eye doesn't really catch the color change as much, right? There's a delay, right? So anyway, the purpose of this video now is to say, okay, I observe this behavior going on where when the feature is disabled and we're for looping through each command individually, we get slower behavior. So then I said, okay, we are going to go to Nsight Systems. Okay, and in Nsight Systems, I run the fast application, which is normal, right? This is a normal fast application. Um, and I'm just basically looking for like what is obvious, right? And so this is the fast application. This is the slow application. And right off the bat, what you can see is that this guy right here, the CPU frame duration. Notice that we have this stutter, right? And all of this stuff is in red. On the fast side, things are in green. We only have one stutter, okay? This guy, we have many things. To be fair, let me hold on. All right, so I was just worried that so I did another fast and slow. I did another profile because I was just worried that the slow was maybe because I was zooming in or out. I was doing something that I maybe didn't do on the fast, but that's not the case, right? So I just basically ran the program, started profiling, stopped profiling after, started profiling after the application settled down, stopped profiling and recorded what happened. We could see this stutter, right? And notice, my big curiosity is that this is part of the CPU side, right? And I'm going to assume that's because that is a topic of conversation because this is supposed to be draw indirect coming from the GPU. I mean, am I to assume that? I mean, I'll have to look into this a little bit more. Right. So, what is happening is that with this we're submitting everything one time. With this one, we have to loop over each each command because we can only submit one at a time. Right. Okay. You see here. It says the second to last parameter is draw count. Right. So the second to last parameter for this thing is draw count. Right. So see how we have the draw count here of 1, whereas here the draw count is the full stack of it's a full stack of commands created one time. Now, we're still trying to figure out, okay, what does this have to do with this CPU and the CPU stutter? I thought we're issuing commands from the GPU. We are still issuing commands from the GPU. The problem though is that when the CPU is building the command buffer, right? When it's building the command buffer, which is what the instructions is the GPU is going to follow, instead of doing it efficiently one time, the CPU has to spend time building the command buffer. Each call has driver bookkeeping, validation, internal command stream writes, etc. Okay? So, that is probably why, whereas with fast, you don't really have that. With slow, you have these stutters here because you have to do that. You also have driver overhead, WDDM submission overhead, right? So, On Windows, this can amplify bursty CPU frame times and show up as stutter in Nsight Systems. So again, it has to do with, now we're looping over each one. We have to submit piecemeal, right? So again, we're building the command buffer, which is a CPU process. I mean, this source code really is living on the CPU, right? So this source code is on the CPU. Obviously, we submit instructions and then the GPU does its thing. And because we do it all at one time, we get the savings here where we don't have as much stutter. And notice this thing is green, right? But when we get to this guy, we could see that there are problems. And actually, this right here is like all of the data that's coming out of it. Notice on the fast, it's just one event, but on the slow, we have a whole bunch of stutter. Okay. Then there's also the issue of command buffer size and cache pressure. So huge command buffers can cause spikes when the driver allocates patches internal memory. So the command buffer is bigger. Okay. These things are going fast and it's a lot of instructions and things that are happening behind the scenes. So it's just more things to manage, right? You have to manage RAM, memory, all that stuff, right? Even when you're just writing the instructions. Yeah, and it's really dependent on how big this indirect command construct is, right? Um, and that's all I basically have. Now, if we investigate, okay, so on the slow, we have this for let's look at the WDDM. So WDDM, I can't really see if that does anything. I don't know I mean, on the fast, we have more red here on the copy, but yeah, I really want to just focus on. So we have this for this guy, this for that guy, but let's not get too. Let's look at the GPU stuff. Okay, so let's clean up and look at the GPU stuff. I mean, there's definitely, this is at 7 seconds. Here we're looking at 4 seconds, but I don't know if this will tell us anything particular. So CPU stuff, the cores, I don't know if that's meaningful. All right, let us go to all right, let's close everything. Do we have a different slow? Thinner on the overall, right? Definitely. Okay, processes. Let's look at processes. Don't know, guys. Do you see anything that's meaningfully different? Actually, let's all right. So let's do this again, and we're gonna expand the threads. Okay, so this is slow. All right. Then we'll go to fast. Yeah, I don't know if this stuff, you know, anyway, guys, I think that, you know, Nsight Systems gives you a lot of information that you know you could definitely work with, but right now. Okay, the 42. So we have 42 here. I don't know. Is the number of threads that we're looking at, is that is that something that's worth investigating? I don't know. But anyway, guys, Insight Systems is it more deals with actual the speed of applications. It's not necessarily you know, looking at debugging or you know, figuring out other issues. It's more just profiling the application to see how fast it runs. Let me just collapse everything just for my sanity. Yeah, we got 29 processes running here, 18 processes running there. Does that make a difference? If we do our second set of things, well, it's the opposite. We get so let me just make sure that yeah, we still get the stutter on the slow here. But yeah, so that is 5.5 ms, 29.07 ms. 99% is less than 6.64. Here, 99% is less than 46. So you definitely see a degradation. But anyway, guys, that is my contribution for today. I just wanted to spend some time investigating this guy because I was curious. I was curious why you know, how poorly was the the performance, you know, when we disable the multi-draw index. It's still being submitted from the GPU, but I guess it's the building of the command buffers. That's a CPU process that and having to memorize and manage and split apart the indirect command stuff. In order to get our this is the problem child right here, draw count 1. Here we have our draw count of everything, right? We have our draw count of everything. The second to last parameter. Here the draw count is 1. So that's our problem child right there. Anyway, guys, thank you for watching. This is CUDA Education. As always, guys, if you want to get involved, have these things running on your computer, you need a Windows-based machine with a Vulkan-capable GPU. A Windows-based machine with a Vulkan-capable GPU. If you want to run the ray tracing stuff, your GPU also has to be ray tracing capable. For our stuff, for this particular application, you don't need ray tracing capabilities, but for the other samples that you run, you need the ray tracing. If you want to run the ray tracing examples, you have to have ray tracing. For NVIDIA, it's RTX and above. For the other vendors, it's I don't know what it is. I don't know what, you know, what generations and stuff. Tutorial number 1 is installing the Vulkan SDK on your Windows-based machine. Tutorial number 13 is installing all of these examples, including this one. So if you want to run this example, you have to have, you know, if you want to run these examples, you have to have tutorial number 1 and tutorial number 13. 13 is where we install all these examples. The best way to learn code is to learn from running code on your machine, right? So you have code running and then you learn from it, you investigate it, you analyze it, you play around with it, you talk about it, you think about it, and eventually you get to a point where you creating your own code, right? But you gotta see stuff for yourself. You have to see stuff for yourself. You have to work through stuff yourself. You have to understand the context and nuance of things. So, you know, yeah, it's one thing to just read a spec or read verbose material on X, Y, and Z, but until you actually see it for yourself on your system and play around with it and see how it behaves, that's when you get true understanding. So anyway, guys, this is CUDA Education. Like, subscribe, check out the tutorials. Also think about Nsight Systems. It's a pretty cool tool. We've been using, as another tool, we've been using Nsight Graphics. But again, that's more just like investigating what's happening behind the scenes. Its focus isn't necessarily on profiling the application in terms of like speed, right? It's more, helping you to get more behind the scenes information, and especially if you're doing something complex and there are crashes and stuff, that's where Nsight Graphics comes in. You could only run the Nsight Systems and Nsight Graphics if you have an NVIDIA GPU. So that's an important thing to talk about. If you have the ability to decide what GPU to get, simply because, like a lot of these tools that I use, it's proprietary to NVIDIA GPU. NVIDIA is the most mature vendor in the GPU space. So there you have it with that. All right, guys, thank you for watching. Have a great day. This is CUDA Education.